Today we're going to build off of the code that we did from 3 days ago. If you've pulled down the repository for the Intro C# online, I have all the code organized by the dates of the lectures. I'm going to copy the code from the 12th, right click that, empty space, right click paste, and I'm going to just change this over to the 15th date. If you worked with code on your own, you should be able to use that as well. We're going to be building off of the previous lecture. Same program. I'm keeping it in a separate folder because it's a good starting point, and then you won't have that change from what we did last time. I'm going to open that up. And to review, we built a simple calculator to compute how much salary you would make over a year if you made $8 an hour with a 40-hour work week. And I'm going to start this up. And those are the default values. We can change this to 10 or 50 if we wanted to, but we have everything already set for this form. So if we hit enter, it's going to compute that. If we hit escape, it's going to close it down. We put these default values in there because we want to speed up our development time. It takes a little bit to every time type those numbers in, and sometimes you get a little lazy because you just want to see if your program works, so you might not put the same numbers in every time. And when you do that, when you're testing out a numerical formula, that can cause problems because you want consistent data because you want to get consistent results. We also have a clear button. The clear button returns the focus back up to the top. So let's just look at the code real quick. Clear is easy. We have txt_hours.clear, txt_wage.clear. A label does not have a clear method, so we have to do .text equals empty string. And at the very end, we want to return focus up to the top. And one thing we would have done after a form submit is to do a select all after this. So let's look at the submit code next. And if we scroll all the way to the bottom, ignoring all that, we can see, yeah, we're doing a focus on that first text box and then a select all. And what that did, if you recall, is, let's say I typed in 10 hours and I hit enter, it brings me back to that first text box and it selects the text because maybe I want to try again for 9. And it makes it real easy. And you usually want to do this so that the most commonly changed element is going to make it nice and quick for the user to update it and not have to fight on that. Let's take a look at the rest of our submit code. We have our pseudocode in here. We always declare variables first. We have one for wage, hours, and salary. And then the next, we get our input from the user. So double wage equals, and this was new to us, we did a convert.toDouble, which is a helper function. This is a library that we're going to use. We're going to say convert.toDouble the contents of our text box. So we're passing in txt_wage into this function. It's taking what's a string. This .text is a string that the user typed in, and it's returning it after it's processed it into our double wage variable. It's putting it into the bucket, into our container, which is double wage, and that is a double of a data type that we declared up here. Same thing for the next one, except on this one, our container is double hours, and we're converting that to a double, but this time we're getting the information out of the txt_hours text box. Next up, we have our calculation step, and we added some additional pseudocode here, and this is really a way of explaining what the calculation is in a little more English, a little more user-friendly talk. So we're saying is you take the wage times the hours per week times 52 weeks per year. And we usually want to spell it out like that so that we can kind of get a great idea for what it is and maybe leave some formulas out. Definitely leave out variable names and all that stuff. The next, we took this formula, we kind of used it as a framework, as a skeleton, and we said, okay, the salary equals the value in double wage times the value in double hours times 52. And it's almost directly underneath that line above it, so you can kind of match them up. You can see, oh yeah, wage, wage, hours, hours, 52, 52. Great. When that's all said and done, this component here is going to be evaluated out to whatever we say. So if we look at our form, the user has 8 for hours, 8 for wage, 40 for hours. So when we look at this formula, the first time it runs, we think, okay, this is an 8, this is a 40, and then 52 is 52. So this really turns into 8 times 40 times 52. And then it's just a simple math problem, and computers are great at that. Lastly, we want to output the results to the user, and that is lblsalary.text equals dblsalary toString. And so we're good to go. And one thing that we ended with is when you have a user that puts in proper numeric data and they hit enter, everything is great. You get the number and that's fine. And some of you that might not have put the default value in would have already have seen this. But one thing that you'll get is if you don't have any data at all and you hit the enter key, you get a little hang on your program, and then you get this yellow bar of death here. You get this exception. It says format exception was unhandled, and you know you did something wrong. And that doesn't mean that we wrote bad code, and it doesn't mean we broke anything. The way .NET will communicate that something happened that wasn't expected was it will generate an exception. And if you think about it, it's an exception to something working normally. And so they're not always bad. It sort of gives us an idea that something happened that us as a developer really need to take into account. And we had said, well, right now there's not much we can do about that. But today we're going to talk about how do you handle when the user enters in some bad input. And let's run this again, because it's not just a space, but maybe they typed in an A, or who knows, maybe they typed in the word 10, for example. And our convert.toDouble here can only handle actual numeric data. So it will work for 8, but it won't work for 8. And when I hit enter, sure enough, I get this exception here. Now, if this does happen to you, you can close the exception down. But that's not going to get your program back to where it needs to be, because what is actually happening here is your program is in sort of a stalled state. It's giving you the chance to maybe see what's going on before the whole application crashes. There are two ways we can get out of this. One is we can go down to our application, which is on our taskbar here, and it's this one that looks sort of like a red square, a yellow square, and a blue square. You can right-click that and close. Sometimes it'll say it won't work, so close it down. That's okay. No big deal. Or if we were to get it to happen again, I'm just going to delete that and run it. You can go up to your debug menu, select that, and say stop debugging. You didn't break your computer. It's just letting us know that there was some sort of error. Now, if we were running this outside of Visual Studio, we wouldn't get this sort of behavior. The application would just shut down on its own, or it might say an error occurred and this program is shutting down. And I think we've all seen applications do that. But since we are running this from Visual Studio will actually attach to the process that is running your program. And that's how we're able to actually see what happens when something goes bad with the code. But enough about that. What we want to talk about is how do we keep the user from crashing our application in the first place. And it turns out there are some more helpful libraries for us as part of the .NET framework. We've been using things like, going into my exit click here, double click, we've been using application.exit is one of them. And another one of them that we've been using as part of the .NET framework is convert.toDouble. So we're getting pretty comfortable with using some things that someone else already wrote for us. And that's what makes a framework. A framework are pieces of existing code that we can use so that we don't have to write everything from scratch. And we're still learning a language. We don't want to write things from scratch yet. Someday we will be able to, and we might want to. Other people say this is great. I don't want to reinvent the wheel. I'm going to move on, and I'm going to use what Microsoft already gave me. So what I'm going to do is, after this first line, I'm going to put another line of code below it that is the equivalent of it. We don't need both. In fact, we're only going to use one of them, but I want to use it directly below there so you can see that they do the same thing. So we want to still get that value out of the text box and put it into our variable. So double wage equals, that's the same. The next part that is different is we're going to use a different library function. The value that we want from the user is a double, because looking at our form, it's a wage. So rarely do we make $8 an hour exactly, $9 an hour exactly. We usually get $8.25, $8.50, something like that. So we're expecting it's a double. Because we're expecting a double, we're going to type double. This is the data type that we're expecting to get from our text box. Then dot, and off of double, it has a helper function called TryParse. Parse is a word you don't really hear people say it very much anymore, but parse really means to read something. And it's not just read, but it's to read something and it's to understand it at the same time. So if you've ever heard somebody say, I'm perusing the newspaper or perusing through the store, that's a colloquialism from the word parse. And so we don't really say it. It's most likely Latin of some form, but it's used in computer science. In fact, if you do JavaScript, a string conversion to a number is actually the parse function. So we have it a little different. We say, oops, TryParse, double dot, TryParse, and now I'll tab into that, do my open parentheses, and I get that tooltip showing up. And we can see, if I were to mouse over this, that the word string s is in bold. And what this is we call this a function prototype or a function header. And this tells us what it is that it expects to be passed. Up to this point, we have been passing all of our helper functions exactly one piece of data. You can see at the line above it, it says convert.toDouble, and then in those parentheses, we're passing it txtwage.text. That is a single piece of data. We say when we're passing a function something, it's that we're passing it an argument. An argument is a single piece of data. Functions can have more than one argument passed to them. In this case, we can see it wants a string. Well, we know what that string is. It's the string of the data that we want to convert to a number. In our case, it's txtwage.text. Now, for functions that require multiple arguments, we're able to tell them apart. We're ready to say, okay, this is the first one. Now get ready for the next one. We separate them out with commas. It's very much like the English language when you're listing off a bunch of things, a bunch of items. So we separate them with a comma, and then we move on to the next one. And we can see the next one says out double result. And so what this means is this is the container that's going to hold the data. And this is a little different than what we've done already. What we've done already is anytime that we're getting a value in our container, it has to be on the left-hand side of the equal sign. So this is actually not needed in this case. So we can get rid of that. We still want to put the value in double wage, but with this function, it actually expects it to be passed. So I will say dbl wage. To end the function call, I do close parentheses and an equal sign. Now the whole time we're doing this, we have a red line. That's okay. Red lines help us out. They're not telling us we're bad programmers. They're going to help us find out what we did wrong. Now it says here, the best overloaded method match for double.TryParse string out double has some invalid arguments. And that is really just, it's unpleasant, and you're going to get this error message, and it's not going to make any sense. And so what we can do is we just kind of hope that we can memorize how to use this, and you can take my word for it because it's a little different than what we've done, and it is going to be different than anything else that we have to do the rest of the semester. It's a bit of an oddity, and that's okay. It's extremely useful, and that's why we're going to use it right off the bat. What's wrong here is that the concept of us passing in this container. Normally, everything that is the container is going to go on the left-hand side, but as I mentioned, this is a little different this time. And because it's a container, it's as if we're handing it to someone else. They're putting the value in there for us and then handing it back. And we say, okay, great, thank you for taking that for me. So what we're doing here is we're handing double wage to TryParse, and we're giving it the text. And it's going to look at the text, it's going to figure out what the number is, and then it's going to put it in our container for us. But in order for us to get that back, we have to put the word OUT in front of it, out. And what that is kind of telling us is that this is going to come back out. If you've had any experience with other programming languages, we would say we're passing this by reference. And that's something that we'll be talking about later this semester. But for now, you just kind of have to memorize the recipe here. We pass it a string first, and then lastly, we're going to say out, and then our container that has the value. So, I want to test this out, but in order to test it out, we have to kind of acknowledge that what happened last time, anytime we put a bad value in here, is the program crashed. And because this old line of code is still here, it's going to get to this line first, and it's going to crash. So we have to comment this line out. We don't want both of them. They do the same thing. So I'm going to run it. I'm going to always test out what I knew worked last time. In this case, 8 and 40, hit enter. That still works as expected. But now I'm going to type in ABC and hit enter. And now it's a 0. And it's not quite perfect, right? Because we know that ABC times 40 times 52 does not equal 0. But at least the program hasn't crashed now. So we're quite a bit farther ahead now. And so let's examine what happened. When TryParse gets a successful piece of data, in this case when it got 8, it reads the text, it puts the value into the container, in this case it's 8, and then it moves on to the next line. And everything is wonderful, and it works just as if we were doing our convert.toDouble. When it gets a bad piece of data, internally it knows that it can't convert it, and so instead of giving us the value or crashing, it will put a 0 in here instead. And often with a formula that you're doing, a 0 is going to cancel out any multiplication you do, right? Because if you do 50 times 50 times 50, it's a big number. But if you do 50 times 50 times 50 times 0, it's always going to be 0, no matter how big those other numbers are. So 0 kind of cancels it out, and that's their way of communicating it back to us. So this works. Now we should move on to our next line. So we're going to do the same thing. I'm going to make the same note. And now we know how to use this. So I'm going to follow this sort of as my recipe. We know that we don't have a number container on the left-hand side of the equal sign. Instead, we do double.tryparse txt hours, because now we're trying to get a value out of our hours text box, comma, and now we have to give it our container that we want the value in. So we say out, because it's coming back out, and we say dbl hours, semicolon, and now we're ready to go. I want to test this, but I can't forget that if I leave this line in, when I give bad input, it's going to crash. So we no longer need this line of code before. And you're going to find this in your programs all the time. You're going to do your code one way, you're going to find something better, and so you're going to have to comment out your old line. And you could say, well, why not just delete it? Well, sometimes it's a good idea to see what you did before in case your new way doesn't work. Then you don't have to scramble back through your code and try and figure out what you did or find an old copy. You just leave the code in there and you can comment some line out and say, well, this is no longer needed because a better way was found. Okay, we have 2 lines using TryParse. Hit F5, submit, everything works great. Change A, that's 0. I'm going to change this one back to 8, and then I'm going to change this one to XYZ. And now my program doesn't crash, it's 0. I can put letters in for both of them, and it works wonderfully. And although, as we said, it's still not the best user experience, it's miles ahead of a program crashing. You can have a wonderful program, but if it's always crashing on the user, it's not going to be a user experience. Think of how you feel when your program crashes. You automatically think that it's a piece of junk. So the last thing that we want is for our program to crash when our users are using it. So what we've seen here is specific to when we use a double. And it's going to be dependent on the kind of data that you're looking to pull out. So we go double.tryparse. And so let's illustrate a different example. I'm going to create a new project. Oops, I have to stop this one from running. I'm going to say File, New Project. Windows, C#. I'm going to call this one Pizza Bill. Leave Create Directory for Solution checked. OK. And we'll make this one very simple. So dragging on a label, a text box, and a button. I'm going to do the usual and make that a larger font size. Align them all to the left. This is going to be called LBL Total. My button will be called Button Submit. Alright, and we'll leave off some of the usual except key presses, the clear, onload, just because I'd like to illustrate a concept here. And so what we're going to do here is we'll create a very simple total calculator system for, let's say, a pizza delivery price. And so I will say all pizzas are $5. Now, we're not going to allow anyone to order a half pizza or 3/4 of a pizza. You will order a whole pizza. And because we're ordering whole pizzas, we would say it's a whole number, and whole numbers are integers. We don't want to allow anyone to say 1.5 or 2.5, for example. So I'll go on my button Submit, and we're going to write some code for that. Now we're going to use our usual formula. We say declare variables, get user input, do calculations, output to the user. So we'll need a variable for our input from the user, which is quantity. So I'm going to say, oops, integer, int quantity equals 0. Oops, there we go. And then last, int total, also 0. Next up, get the user input. We want to get an integer from the user, and we want to use TryParse like we did in our last program. Instead of saying double, we need to acknowledge that we're trying to get an integer. So instead, it's int 32, because that's what the data type is, dot TryParse. And now everything is just as it was in our other example. We say, oh, we didn't name our text box. In this case, it's text box 1. We'll have to go back and change that. Dot text, comma, out int quantity. This is the container that we want the value to be in. We're passing this container to TryParse along with our string, and it's going to do the computation for us about how to convert that over. We don't care. We just know that it works. And when we're done, we have that number in our bucket. Next up, do our calculations. So we said int total equals, and what do we talk about? All pizzas are $5. So I say int quantity times 5. Lastly, output to the user. We didn't name this either. Or did we? We did. LBL total dot text equals int total. Now, I'm just going to tab into it and hit my semicolon and hit enter. And that's okay. We know there was going to be an error. We learned that last time, but that's okay. We're going to use our error messages to give us some hints. And this one says cannot implicitly convert type int to string. And that means that it wants a string, but it is an int. So to do that conversion, we say dot toString. Open parentheses, close parentheses, because it is an action that we're doing, a method. Now we're ready to run it, hitting F5. And we can try this out. It's not pretty, but that's okay. We just want to see what happens. So I'm going to order 2 pizzas, hit submit, and we have $10 as a total. Hitting in 4, 20. That's great. We expected that. But having an empty input and hitting submit is 0. Going back to 3, it works. If someone tried 3.5, it's not going to work. It's going to get a 0 on it because 3.5 is not a valid whole number, and so it's going to get 0 for it. On our other application, pulling that up again, if I were to run this one, we have 7.5 already, and so you're not going to get a crash from it. It will accept a decimal point. But doing int 32, which is integer TryParse, it's not going to allow that. So there might be situations where you don't want to allow the user to do it, and therefore you wouldn't use double.TryParse. You would use an integer.TryParse. Now the only thing about this one that's bugging me is if I put in 2 and hit submit, it says 10. And wouldn't it be nice if we could have it be formatted like a nice numeric dollar amount? And so to do that, clicking into my button submit, and I go down here to where it says toString. And you'll notice that at the end we have that open and close parentheses. That means it's a method. It's a helper function. So we see that this one, we pass that one in arguments. It's got text box 1.text, comma, out in quantity. It takes 2 arguments. And this one has none. So a function can have 0 or more arguments. And in this case, we don't need to pass it an argument, but we can. And what you can do is you can pass it some codes that will tell it how to format your data out. And so if you don't tell it to do anything, it's going to guess what you want. But what we want to do is we're going to pass it a letter C. So we say quote C quotes. C stands for currency. So hitting start and typing in 2 and submit, it will format our value out as a nice dollar amount. So we have C for currency, lowercase c, and now we have our numbers formatted. And if you want to go in and clean this up, that would be a good exercise. For now, I think it gets the point across. So what we have is really a nice way of getting integers out from the user if they type something in bad. And also we have a way of getting doubles out. So we really don't have any reason why our programs should crash anymore. And this is a giant step from it, because before this we're saying, okay, well, let's just hope that no one types in bad input. And so it allows us to make significantly more sophisticated applications and provides that user experience where, yeah, the program shouldn't be crashing for them.